So throughout the course you are going to come across quite a few new terms. You will hear about earth resistance or earth continuity. I personally don't like continuity because it only indicates that there is a continuous circuit, whereas the resistance we need to give a specific resistance of 1 ohm for the earth resistance. But that creates confusion between the earth resistance and another one. Another term you're going to hear will be earth leakage. You'll also hear it referred to as a power-up test or a run test, or probably a few other terms. The next one you'll hear will be insulation resistance test, sometimes called a static test. When people first start out in this, that is probably the most confusing thing that they have, understanding the difference between those 3 terms and how to do the 3 separate tests. Between that and identifying classes, that is probably the most difficult thing you'll have to do. So what I'm going to do in the next series is try and explain to you simply how these tests are done, what they mean and what the differences are. Okay, when you first look at this, it's going to look very complicated. But keep in mind that this is not how the test is done. The only purpose of this is to show you how the test works. To put you back at ease, I'll show you at the end of each section an animated video of how simple it really is to do the test. So don't freak out over this. It is only there to show you how the test works. Right, the first one I'll try and demonstrate is earth resistance or earth continuity. Here I have my rusty old soldering iron. You guys are going to get sick of seeing this, but it's an excellent demonstration tool. You'll see I've made a connection to earth, and the earth wire goes back to the plug and plugs into the tradie unit. The first thing you're going to notice is there is nothing connected to the main working circuit. The reason for that is quite simple. The earth is only a protection. It has absolutely nothing to do with the working circuit. It is only there in case there is a problem. In a perfect world you do not need an earth, but unfortunately, as I've said often, the world is not perfect. The earth is only there as a backup system in case something goes wrong. And like all backup systems that are invisible in normal working conditions, they have to be regularly tested. And this is how we do it. We connect the probe to exposed metal. Now I'll just zoom in on the screen so you can, oops, wrong way. So you can see the result. You can see there that it is just flickering. If I take my screwdriver and I just fiddle with that earth, you'll see that I only have to turn it half a turn That's all the difference is between a pass and a fail. Okay, you'll notice that the earth wire is connected directly to the unit, to the normal earth pin, to there. The probe is connected. That gives me a return path. I'll just zoom out again. And there you can see the earth connected to the unit, to the earth screw, to the probe connected to the exposed metal, and returned back to the probe connection on the tradie. This is the earth resistance test. It tests the resistance of the circuit from the earth, through the earth wire of the lead, to the earth connection, and back to the trader unit. It has to be less than 1 ohm, and that is the earth resistance, or sometimes called the earth continuity test.
We're going to test an earthed appliance. That's class 1. So we'll need a test probe to check the earth. In fact, the procedure is the same for class 1 and class 2. The difference lies in the interpretation of the results. The class 1 appliance in this case is a toaster, and it's safer to assume that the appliance may have a fault until we've tested it to prove otherwise. So firmly clamp the earth probe onto any exposed metal we can find, check that the appliance and the Mega are both switched off, and plug the toaster into the top socket of the Mega. Switch on the Easy Test Mega, and immediately we see that the earth resistance is tested and passed. And on the bottom line we have a class 1 pass, indicating that there's no leakage current, or if there's any, it's below the 5 mA safe level set by the Australian standard. However, some faults only show up when the device is live, especially those with moving parts like motors. So switch on the appliance, check that we still have a class 1 pass, and the appliance passes. Test completed. It's that easy. Switch off, unplug, and tag it.
Right, the next one we'll look at is the insulation resistance test, sometimes called a static test. The insulation resistance test differs from the run test or the earth leakage test in that it is a stress test. We put 500 volts between the active, neutral and earth. We join the active and neutral together and put 500 volts to earth and try and blow a hole in any weak point. So let's see how it works. This is the Easy Test Mega. It is the only one of our range that does the 500 volt test. The Duo and the Mini Pat only do the run test. This one does the run test and the 500 volt test. Okay, so how have I connected it? I'm plugged into the unit, and you'll see here I have connected the active and neutral, you'll see them close up in a minute, together, and I have connected the earth, and the earth probe is connected to the exposed metal and plugged into the unit. You'll see the class 1 earth resistance pass on the top line. Again, if it's class 2, it doesn't have an earth, so you can ignore the top line. You'll see it says select test. In this position, you will see down here, I'll just zoom in now so you can see how that works. You'll see RCD start test button. If you push that button now, it will trip the RCD on the main switchboard because that is what it's designed to do. This unit will test either fixed RCDs on the switchboard or portable RCDs by plugging them in. But if you push that button, you will trip the RCD on the main switchboard. So unless you really want to do that, don't push that button. Okay, to start the test, be in the select test position, check that your earth resistance passes if it is class 1, then select the voltage that you want to test at. So we push the 500 volt test button. You will see it goes into a continuity check. It checks that the continuity passes. It then goes into an insulation resistance check, and it is now putting 500 volts between the two working circuit pins, the active and neutral pins, and the earth wire.
When assessing the insulation of an appliance, the Mega enables us to check either leakage current in a run test, or to check insulation resistance by applying a voltage across the insulation. Since an insulation resistance test will not power the device, that's what we'll use to get an initial assessment of more aggressive equipment like this big angle grinder, where it's more comfortable and possibly physically safer than to do a run test. Although it is industry best practice to perform a run test on any device with moving parts. Just like the run test, we need the probe for an earth connection, so connect it to the metal of the tool. It's safe to clip it there since the tool won't actually be spinning. Ensure that the rocker switch is off and, remembering that for this test we use the bottom connections of the Mega, plug in the appliance. Switch on the power, and at this stage the earth continuity is checked, and for a class 1 device earth resistance is shown as pass or fail. However, since this grinder is class 2 we can ignore it. Press the 500 volt button and the Mega first checks for continuity, that is, a complete circuit. In this case it's failed, suggesting a run test is needed. However, it's only because we've not switched on the tool. So close the switch on the tool and try again. Continuity is OK now, so the insulation is checked, and it passes. The test will automatically terminate in 30 seconds, or press the 500 volt button again to stop it now. Test completed. It really is that easy.
Okay, the next one I'm going to try and demonstrate is the earth leakage power up run test, whatever you like to call it. And this is a little difficult because with the others it's not in normal operating condition. It is, I could quite safely strip the soldering iron down, add and subtract resistors, whatever I like, or twiddle with the earth wire. The run test is different. The run test is done at full mains voltage in normal operating condition. And to that end, I have decided that for safety reasons, I'm not going to try and simulate it. I'll just have to try and explain it. So I'll do my best to simulate this on the bench. I hope I get the message through, but this is the main difference between the power up test and the insulation resistance test. It is done under normal operating conditions, whereas the insulation resistance test is done using a generated 500 volt supply limited to just over a milliamp. So it isn't lethal. It hurts, but it isn't lethal. Alright, now we'll have a look at the earth leakage test, or the run test, or the power up test, whichever you prefer. To do the test, plug it into the top. I'm still using the Mega. The Mega will do either. Plug it into the top of the Mega. It says here, testing connections run test. As always, connect your probe first. Check your class 1 earth resistance pass. Obviously, if it's class 2, it doesn't have an earth, so you can ignore that. Turn your rocker switch on. This is an early model. It doesn't have the 5-second delay. On the later models you have a 5-second delay. It still says class 1 earth resistance pass, and if there was any earth leakage that would show class 1 or class 2 fail. So what we're doing here, that iron is getting hot now, and we have it in its normal operating condition, and we are measuring any earth leakage, any leakage through the insulation going to earth, back along the lead, back into the unit, through the measuring device in the unit, and back to the main earth. I'll just turn that off because it's starting to get fairly warm. And that's something you have to be very careful of when you're doing this test, that it will be in its normal operating condition. So that's the main difference between the earth leakage test and the insulation resistance test. In the earth leakage test, we are measuring the current leaking through the insulation in the unit, back through the earth wire. And in the insulation resistance test, we are putting the insulation under stress and trying to blow a hole in it.
We're going to test an earthed appliance. That's class 1. So we'll need a test probe to check the earth. In fact, the procedure is the same for class 1 and class 2. The difference lies in the interpretation of the results. The class 1 appliance in this case is a toaster, and it's safer to assume that the appliance may have a fault until we've tested it to prove otherwise. So firmly clamp the earth probe onto any exposed metal we can find. Check that the appliance and the tradie are both switched off, and plug in the appliance. Switch on the tradie, and immediately we see that the earth resistance is tested and passed. And on the bottom line we have a class 1 pass, indicating that there's no leakage current. or if there's any, it's below the 5 mA safe level set by the Australian standard. However, some faults only show up when the device is live, especially those with moving parts like motors. So, switch on the appliance, check that we still have a Class 1 pass, and the appliance passes. Test completed. It's that easy. Switch off, unplug, and tag it.